Hello friends, today in this video we are going to discuss another problem of data structure. Find the smallest subarray length whose sum of elements is greater than k. So k is a target some number and you are given with an input array. Here in this example 1, 2, 3, 4, 5, 6, 7, 8, right? And your target number is 21. So you have to find a subarray which will contain whose elements contain a sum of 21 greater than 21, and you have to return the length of that, and the length of this subarray should be the smallest. So let's go through this problem graphically. So here we have an array 1, 2, 3, 4, 5, 6, 7, 8, right? And our target number is 21. So let's look whose element, the length of the minimum subarray whose element contain 21. Or let's take a look first of 10, right? So if you keep summing up this element 1, 2, 3, 4, 5, 6, this is 10, but equal, we need the equal greater than, right? So this is the element of this subarray is more than 10, which is 15, right? But if this is the length is 5, but if we calculate this particular subarray from 2 to 5, then its sum is 14, right? So the length is only 4. And same if we just take this subarray 3, 4, 5, right? So its sum is 12. The length is 3 only, right? And if we take some more elements, for example these two, right, sum is 11, which is greater than 10, so length is 2. So this can be the minimum length subarray which contain the elements whose sum is greater than our target. But there is no subarray of length 1 whose sum is greater than k, right? So our answer is 2 in this case. So let's talk about how we can fix this problem. This is a classic problem of sliding window. We can move the window, which can shrink its size on both sides, left side and right side. So let's walk through this problem. So let's say we are increasing the length, right? And whenever there is any we achieve the target, right, then we can find the minimum length of that, and we can have one variable which is, let's say, the response, right? And it could be the minimum length. So if we find any other subarray whose sum is greater than our target number, then this response could be updated with the minimum value. And when we can increase on the right side, also we can decrease from the left side. So if we have increased the right side and number is greater than our target, right, then we can keep on decreasing this on the left side so that we can find the minimum length. We will apply this technique of sliding window with variable size on both sides. So you can guess what should be the complexity of this problem. You can increase this length on the right side, and at the same time you have to decrease the length on the left side every time, right? So it could be at max n plus n, it would be on, right? So let's take the code of this problem. Here is the code. Minimum length, we are given an array and a target n, and we will return some integer which will contain the minimum length of this subarray. So we have created two variables, L and R, which is left and right pointers for the sliding window, and the sum, we have taken the sum of the first element, and our response, which is basically the length of the minimum length of the that array, subarray, we have taken the infinity, right? So we are now doing the while loop. The conditions for this while loop are: the left should remain less than or equal to right side, and the right side should be less than the length of the array, which is fair, right? And if length, the left side, is become greater than r, right side, the pointers, then the right pointer should be increased, and we will continue. Here is the logic. If sum, right, the sum of all the elements we are calculating on that sliding window is greater than our target, then what we will do? We will calculate the minimum value from our right pointer to the left pointer, r minus 1 plus r minus l plus 1, and the minimum with the existing value. So this will be our response. And after this, we will decrease the left side. We will decrease the window from the left, which is, we will, from the sum of the sliding window, we will remove a of l, the left pointer, and we will increase the left pointer, which will basically these two things, sum become minus of al and l pointer is incremented. Then we again go to the loop, and if their condition are matched, we will keep doing this, sliding the window from the left side till our sum is less than our target, because that if target sum is less, then only we can try to increase the right side pointer. So if sum is not greater than our target n, then what we will increment the right side and will update the sum if our target right pointer is less than a. So this is to avoid the unbounded access of that array. So sum we have incremented, and then we are looping again, right? And at the end we will return whatever the minimum value we found in the response. So I have taken a sample input which we have discussed in our example, 1 2 3 4 5 6 7 8, and our target is 21. So let's see what it prints. So 21. Can you find what are the numbers? 21 could be created through multiple ways: 5, 9, 14, 20, and then 27. The length is 6, right? So what could be the minimum? When we, I think these three will have what? 21, which is equal to, but our problem is greater than, right? So we have 5, 6, 7, 8. So I hope you got the concept and you got the code, how we are iterating on this array and finding the our answers. So here, this is the classic problem, sliding window problem, and there are many problems which can be solved through this sliding window concept. If you master this, and there can be multiple forms that sliding window can occur. Either the window can shrink on left side or right side or both the sides, or there can be some cases of fixed window size. It depends problem to problem. So if you got the concept of this, please like the video, share and subscribe to the channel. Thanks.